Hello, and welcome to Patio Cover 2020. So this all started with this patio umbrella. And this patio umbrella was next to our house and sat over some furniture, and it gave some pretty nice shade. But it had a few problems. And the first was, it was just too small. Whenever it rained, we didn't want the furniture to get wet, so you kind of have to push the furniture together in the middle. And that was a pain, and sometimes you forgot. And then during winter, it'd get blown all over the place. So you had to take it down and put the furniture somewhere else. And then this summer, it developed some degradation, and we started getting big holes in it. So the first discussion was, should we just replace the cover? But that quickly changed into a discussion about other alternatives and awnings, and then finally the patio cover we ended up building. I'm going to start with the design. So I like to do my designs in Fusion 360. It's particularly good at playing what-if games, and then I can make sure that the parts that I order are really the parts that I need. So this design, let me turn off the roof for a second. This design is really pretty simple. What we have here, we have the house back. We have a set of French doors. These two things in the foreground are planting beds, so it's important to know how much space we'd have. And then this, whoa! This little platform here on the side is what we call a decklet. There's a set of stairs that come down this side, and then there are small steps that go that way or this way. And we had to make sure that the post at this end of the structure wouldn't interfere with the decklet. So that's why it's drawn in. And the design is really pretty simple. We have across here, we have 3 6x6 posts. You could probably get away with 2x4s, but 6x6s just feel a little better. They feel a little beefier. Then we have cross beams. These are 2x10 bolted to the posts, and you can see there's one kind of on the side facing us, and then another set on the side behind. And then on top of that, we have rafters. The rafters are 2x6s, and they're attached to what looks like a ledger. Originally, I had a full ledger there, but it turns out our house is kind of built with a band that runs around right at that level, kind of a built-in ledger. So instead of adding another ledger, we just ended up attaching that more firmly to the house. So this was the basic design, and then we had to figure out how we were going to cover it. And our first plan was that we would put transparent polycarbonate on top of it. That would give a shade, a little bit of shade, but that would still give us some light. That's what we did with our deck, covered deck next to our kitchen. But we talked about it some more, and there were some problems. The first is sometimes you really want a lot of shade during the summer, and this would still let in quite a bit of light. And the other problem is that the polycarbonate panels and all the channel that you use to attach them and make sure they're waterproof and all of that tends to be pretty expensive. It looked like we were well into the range of $1,500 just for the roof, and that seemed kind of a bit excessive. So I kind of put those together, and we decided to go with a solid roof. Now, for a solid roof, there's not much pitch here. One of the things we did, because of the decklet at this end, we wanted to make sure there was enough clearance when you're walking from here to the joists. So we designed one with not a lot of pitch here. It's a pretty flat roof. We could have actually probably doubled the pitch. This is a 6-inch droop. Could have been a 12-inch droop, and we probably still would have been fine. But that still would have come up as a low pitch roof. And that requires some special stuff that I'll talk about later. So eventually we talked about what we wanted, and we ended up choosing a metal roof. So back to the PowerPoint, that was the design. When you choose a metal roof, you need to decide whose metal roof you're going to go with. And we ended up going with a local company called Champion Metal. They make roofs. There's a nice picture there in forest green, which happens to be the color we chose. And you can see this is a type of roof called Snap Lock. And it's what's called a standing seam roof. So it means essentially it's kind of confusing here because they're showing the next panel coming over. But essentially we have this side is what's called the male side. No, the female side. This side is the female side. And then this side along that edge gets screwed down. And then you just move from left to right or right to left, depending on which direction you want to go and install them. So this is the installation guide. I spent a lot of time looking at the installation guide because unlike shingles, in metal roofs, things like this spacing, this is a 12-inch spacing, and making sure that things work out with the clearances at each end is really important. It's not like you can just buy an extra thing of shingles. Oh, and the other part is when you order this, everything you order ends up being what's known as a custom order, which means you can't return any of it. So you need to spend a lot of time with your installation guide and maybe consult with the company to figure out whether you are ordering the things you need. So I figured out everything we needed, and a little while later this showed up in my driveway. On the bottom there's a bunch of plywood, which will be the deck. Kind of in the middle is the posts and the 2x6s, and then on top is 20 panels for the roof. Not shown, there was a bunch of flashing too. That's already in the garage in this picture. So the first question is, how do you attach the posts to the footings? And Simpson Strong Tie makes a really interesting post base. We wanted something that looked fairly minimal, and they make this post base called the CPT. In our case, it's a 66, since it's for a 6x6 post. And basically what you have is you have the metal part here. So it has one flange on this side, one flange bent away, and then some sort of bolt into the actual concrete. And then you end up with that in the concrete, and then this little black part is just a cover that slides down over it. And then to attach the posts, you take the posts and you cut a slit in the post that slides over this part, which we call the blade. And then you've drilled holes through the post, and you put dowels, which are steel galvanized, and you drive them through, and that's what attaches the post part to the blade part. So I decided to use this sort of thing. And this is what the posts look like after a whole lot of wood preparation to make them look pretty, to put some finish on them. You can see here there's a slit. You can see the 3 slits cut, and then 3 very carefully spaced holes drilled on a drill press. And how I got the slits and the holes cut is a long and involved process, because these are Douglas fir, which means they're really heavy and dense. The 10-footers probably weigh 50, 60 pounds each. So they're kind of hard to move around. And dense and heavy and kind of ungainly. So I have some video on that. I may actually do a separate video that shows how that happened. For finish, we use a product called Cetal. I actually, unfortunately, chose the wrong picture here. Cetal used to be made by Sikkens. It's now made by PPG. It's the same thing as before. And we were originally going for cedar, but because everyone is trying to do home projects, especially decks, and there's some supply chain issues, we ended up going with teak, which is not quite as orange, but still turned out pretty well. So I spent probably a week or more doing sanding, planing and sanding and more sanding, and then ultimately finishing all of the wood ahead of time, including one side, the exposed side of the plywood. And it's kind of a big pain to do ahead of time, but then the nice part is after that, then you are finished and the construction is much easier. So I heartily recommend doing that. So starting at the bottom. So this is one of the posts, and we need to have essentially a hole in the pavers where concrete can come to the same level as the paver. And in that little bit of concrete, we're going to embed that post fitting, post base. So essentially, we took a measurement off of the house, used a line to make sure, chalk line, or not a chalk line, a string line, to make sure that it was as perpendicular to the house as possible, and then figured out the middle post location. And then the other two post locations are determined off of that. So you can think of the center post as the most important post. And then from that, put down this trim base, drew around it with a Sharpie, and use that as our guide for cutting. And the cutting, I'll show you the tool in a minute, but the cutting was done with a diamond wheel. And then once you have that, then you can make these little pavement lifters. You can buy pavement lifters like this, I think, but I decided to make them out of a clothes hanger. And it's actually hard to find clothes hangers these days. Most are plastic. So you put those little pieces in, twist them to the side, put those wood blocks underneath the kind of square parts at the bottom as handles, and then use that to pull the paver up. And then you can do the same cuts from the backside. So here's the tool, upper right, it's a 7-inch Makita angle grinder. I tried initially with abrasive wheels. Abrasives didn't work, so I went and bought this nice rigid diamond masonry wheel, and that cut extremely well. Cut very quickly and very cleanly. So I used that. We cut from the front and then cut from the back. But that's still left. Look at this. You can still see there's little parts in the corners that we're going to have to cut some other way. So I went and found, I usually don't buy much stuff at Harbor Freight, but I found that Harbor Freight had some cheap diamond recip blades. And they were cheap and didn't really cut very well, but they cut just well enough. So that's how we ended up with this. So this is one of the footings. I think this is the opposite end from the decklet. Doesn't really matter. So pull the footing up, set it to the side, and you can see we have a sand base underneath. There's a sand base and then a bit of gravel, and then we get down to normal ground. So next thing, dig out footings. My goal was about 13 inches across and about 13 to 15 inches deep. So there's one. The first two are pretty easy. The decklet one was pretty fun because there was that corrugated drain line at the bottom. Luckily, we had redone the drain lines, and the real drain line no longer runs in this area because we redid it, and it's now nice PVC. So this was abandoned, and I could just cut it up, and we could get down to what we really wanted. So another picture, those all three ready to pour concrete. So we poured the concrete. Essentially I pour the concrete most of the way up to what the sand level was, and then put the paver back down, and then fill in the hole, and then kind of fill in the paver depth here. And then we had a problem. The problem was, how do I get those Simpson post bases embedded in the concrete exactly the way I want them? And this is what I ended up doing. So we can use, essentially I used a level on the side, combination square on the side of the fitting to determine whether it was plumbed vertically in both directions. So that controlled whether it was straight up and down, and that's what I wanted. And then we could use the little black cover, the post base cover, next to it. Each of these connectors has a couple little arrows on it that show you where that line should be. So you can essentially adjust it up and down, and then eventually you get to the point where you're happy with it, or at least happy enough with it. And this is the middle post. And you can see this looks pretty much the same as the last picture, except there's, in the back, there's kind of that block with some wood and then another piece of paver on top. And that's to set the angle right to left. And I did that on 2 of them. 1 of them I didn't need to do that. So got that, kind of cleaned up the concrete, everything got set, let that set overnight. And then we ended up with this. And okay, we didn't quite end up with this right away. If you look, you can kind of see that the black base part is recessed a little in the concrete. And it turns out that this particular connector wasn't quite high enough. And it meant I had to go back and kind of do some cutting and a little chiseling to get the level correct for the connector. But that really wasn't that bad. It took a little while, and then I finally ended up with this. Then we could put the post on for real. So that's the post on, and with the dowels driven in about halfway. I'm toying with the idea of what to do with these holes. I think I have 3 options. I could either just leave them. I could paint them black on the inside of the hole and the galvanized part. That would kind of match the black theme of everything else. Or I could take some other dug fur that I have and make plugs. These holes were cut with a Forstner bit, so they're nice and smooth. I'll make plugs and put them in, and then sand them down and refinish them. And that would look like, you know, I would, that way you wouldn't see the material. I'm kind of leaning towards doing the black, but I haven't done anything yet. And there's a post sitting up for real. And at this point, the posts are pretty wavy. You know, you have a lot of weight up in the air, and that connector is pretty solid, but it's really not designed to keep the top from moving left or right. It's designed to just make sure the connection is good and solid. So the next step was to trim the posts to the proper length. And the way I did this was I took a nice straight rafter here. So that's a 2x6. The end kind of behind us is in one of the joist hangers, or rafter hangers in this case. And then I took the end out here, put some clamps on so I could hold it up, and then moved it up or down until it was absolutely level. So that tells me where the level part is, and then I know that I need to be 6 inches below. Well, it's actually not 6 inches because there's some overhang. So I went back to my Fusion drawing and did some measurements there and found that it was actually 5.5 inches on the face that's towards us. So you do that, put that in there, mark where the actual line should be, and then take this down, put the whole post on a chop saw and cut it at the proper angle, which happens to be 2.4 degrees, if I remember correctly. And then you can put the post back up. So did that for all 3 of the posts, and now is the point where I actually put the dowels in. Before they were just, the posts were just there and kind of braced up. So I have 3 posts. That's good. What's the next step? So the next step is this really complicated picture. And I have to explain a few things. So first, obviously in the middle, we have the post. And what I'm starting to do is put on the crossbeam that's going to go off to the other post at the right. And it's really important as I start drilling holes that this post be perfectly plumb, or as perfectly plumb as I can get it. So I did 2 things. First of all, the joist here, the rafter, is attached into the joist hanger behind, so that's a solid connection. And then in the middle, on top of the post, you can see that there's a little bracket. And that bracket holds the post from moving left or right, or closer or farther from the house. There's a bracket on this side, bracket on the other side. So that constrains the post in one plane. And then the 2x4 in the upper left is kind of attached, and actually has a big concrete block on it down on the patio. And then up near the top, it has 2 screws that go into the top of that 2x6 rafter. So that constrains it in the other plane, and that makes sure that it's exactly where I want it. Then the short piece of pressure treat 2x4, the cross piece there, you put that up kind of in the ballpark of where you think you want the 2x10 to go. And do that on this post, do that on the next post down, and then hoist that up, and then you clamp it in place to hold it at the other end, and then at this end you can adjust it left or right a little and make sure it's up tight against the 2x6 because it needs to be supporting it. So you finally do that, you adjust your clamps a bunch of times so it's exactly where you want. And then the lighter wood block is a 2x6 with 3 holes drilled into it. And those 3 holes define where the mounting hardware should go. So those were drilled through with a drill press. And since I need to go through this 2x10 and then the 6x6 post and then another 2x10, I need holes that are really pretty straight. So you put that up and drill some holes through. Holes aren't quite all the way through, but then you can do this. And right here in the middle, these 3 pieces, this is all thread, so threaded rod. It's spray painted black, so it will look black at the end. And those are just kind of lightly tapped into the holes. So they're hanging on the partial hole that we drilled into this 2x6 and clamped on. So we've done that at this end, and the reason I bothered to put these in right now, even though the holes aren't drilled, is I kind of ran out of clamps. I didn't have enough clamps to do everything I needed at this end and everything I needed at the next post. So this way, hanging on this and with this one clamp, it's really secure. And you go to the other end, make sure that post is straight in 2 planes, and then you can go ahead and do the same thing. And you'll notice here, not only do I have the close one, I have the far one, and then I have hardware on here to attach. And the drilling was kind of fun. This is so 5.5 inches plus another 3 inches, so it's 8.5 inches, which means you need a 12-inch bit. And I couldn't find a cheap, I didn't want an expensive, a cheap 12-inch bit, but I did find that Harbor Freight had a very cheap 24-inch drill bit. So you can see down here in the drill, this comically long bit. So I drill through as far as I could with the normal bit, the one sitting here, and then go the other one and go all the way through. And it worked okay. We'll later see a picture that shows that the alignment isn't quite as good as possible, but it's not horrible. So we have for the hardware, so we have the threaded rod, this diamond shape, or actually square shape, is a Simpson 2x2 thrust plate. So it's just a flat piece of metal with a 1/2 inch hole in it. Then there's a galvanized washer, flat washer, and then finally the galvanized nut. And all 3 of those were galvanized colored, and they're spray painted black. So got those up, everything's where it wanted. These are nice and tight, and that's what we have. And then we go off and simply repeat for the other end. So this is all the basic structure. And at this point, the center post is exactly where I want it. These posts are plumb left to right. They aren't yet constrained towards the house and away from the house. That'll happen when we put on the rest of the rafters. And that, of course, is the next step. So, and this is the first time we've seen these joist hangers. This is part of Simpson's line. I think it's called Outdoor Accents. So these are really nice. The bolts, these are structural screws, 1.5" structural screws. There are 6 that attach this to the ledger, and then there are 4 that attach the connector to the rafter. You know, there's a couple things. This ledger is what I was talking about. That's a feature of the house. Just wraps all the way around the house. So we decided to hang on that, but we didn't think it was very well attached. So these little dots here are, I think 4-inch, either 3.5 or 4-inch Simpson structural screws that go into the floor joists. So that makes this ledger more than strong enough to be able to hang this. So we now have the posts and the beams and the rafters. That's pretty much all of the base structure. And we're going to move on to plywood. And in this picture, first off, go off and look here at the right, and you'll see that this first set that I didn't really end up drilled very straight. They're functional, but not really particularly straight. These ones are actually pretty close. Oh, and I forgot to say the other side, the other ones, they're arranged in diamonds because that's what we did on the kitchen deck. So it kind of gives us a common design element that is across both structures. So now we're in the middle here. We're in the middle of doing plywood, and I have a little clamping here that I didn't take a picture. I didn't take a picture when I set it up, but I took a picture later on. And the reason this clamping is here is that this 2x6 has a fair twist to it. So this top is considerably to the right, and we need it to be back where it's supposed to be, especially because it happens to be on a plywood seam. So the first thing that I did was went to the back side here, and we measured off the distances between the rafters, and then the rafters are now held by another Simpson outdoor accent bracket. So that bracket keeps the bottom from moving left or right. And then this little clamp assembly, we pull down on that, and that moves the top to the left and gets it in line. And then once it's in line, all the plywood is all screwed to the rafters, so that keeps it where it's supposed to be. And in addition, this was the first part, so that kind of set the twist of the rafter, whether that was correct. And then we also went in on the first sheet of plywood, and some of these rafters are bowed, so they might have a bow to the left or a bow to the right, and you don't want that either. So they are moved to the left or the right before the plywood is attached down to make sure that everything's good. Okay, so this is tongue and groove ACX underlayment. And the ACX means that it has one A side that's actually pretty nice, doesn't have any voids or stuff. This is the C side. So yeah, there's a void there, there's some void there, and void there. So the nice part is down. X means external glues. So the first parts went fine. You know, this one went on easy, next one went on easy, and then these ones, the tongue on this one needed to go into the groove. No, the groove on this one needed to go into the tongue on the left. And the traditional way of doing that is you put the piece of plywood there, you take this piece of wood, and then you put it on top of the groove, on top of the tongue, and hit it with a sledgehammer, and that drives it back in. And it worked great for this row. But we get to this last row, and it's designed to be really close. There's probably only a 1/4 inch here. And I tried a couple things, tried pry bars and a couple other things, but could not get this joint to close. And that's not only important from a strength perspective, it's important from an appearance perspective from below. If you don't get it to close, you'll see a gap below, and that's unfortunate. So I went and grabbed some of my tie downs. This is, I have 2 ratchet straps. Actually, I have 3 ratchet straps, and then the ratcheting here. And what you can do is tighten the ratchet until it's pretty darn tight, and then you walk along the seam and kind of bounce to try to move the tongue and groove part back and forth in relation to each other. And you do that a little bit, and eventually you hit the right combination and it just pops in. And I had to do that for all 3 of the panels. There's two full sheets on this side and then a half sheet to finish. So I had to do that for all of that. And then we had the plywood done. Well, then I went back and did screws. Here we only have a few screws showing, just enough to hold things together. So I went back and added screws across the whole field. So now we're in a good shape with the deck. And what's next? Well, one of the things I said earlier was this is a low slope cover, and most roofing just doesn't work well with low slope. The problems you get are that the water, because the slope is low, the water doesn't really want to easily run down the slope, and that means wind and other things can easily push it to the side. So since I was doing low slope, I decided to do cheap insurance, and this is Grace Ice and Water Shield. There are some other companies that make it, but Grace does a really nice job in my opinion. So what it is, it's kind of this asphalty, sticky membrane underneath. And you just, here I've done this thing, put a clamp here, you cut the backing, and then as I start pulling on the backing, the roll will roll over and start adhering. And you just have a certain amount of overlap you need to do. So go over and back and over and back and over and back, and you're done. And then you end up with your roof looking like this. There's a little overhang on this edge, going to cover the plywood. And then on this edge, there's a couple of inches of overhang because that's all going to be covered with flashing later on. And this gives us a very homogeneous monocoque one-piece roof. So water, here just rolls and rolls and rolls and rolls and rolls and rolls. So this is one of the mitigations for putting down a pretty flat roof. If the water gets through the metal part, it's not going to get through this. And the other nice thing about the Ice and Water Shield is it shields around nails and screws, seals around nails and screws pretty well. So that helps you a bunch there. So now it's time to go on to the roof. And the installation guide has a lot of useful diagrams that you need to understand pretty well. Sometimes they're a little confusing. So this is the edge, the low edge away from the house. And looking at this bottom diagram first, you start, they have what they call a hook eave. This is really the drip edge. So this is the first thing down. And then on top of it, it has this little cleat. And the reason, looking at the top, the reason you have that cleat is we're going to take the panel, we're going to make a notch, and then we're going to bend under the unnotched part or the flat part of the panel, and it's going to come back and hook on to that little piece. And that kind of helps everything to go together. Now, if you look at these drawings closely, you'll notice in this one, that little cleat sticks out maybe a couple inches beyond the edge of the roof. And here it's held back half an inch. And this is pretty common of these sort of drawings. A lot of times they just really do not have the information that you're looking for, or they're confusing. So I decided this bottom part was the right approach. So here we are having put in, you can see the green is the drip edge. The cleat is not painted because it's not going to be exposed. And then on the right, I have gable flashing just sitting there because the gable flashing needs to be right on the roof. It doesn't need to sit on this. So we essentially put this all the way across, and then I put cuts into it. Another problem with the low gradient roof is that water, I didn't think water was actually going to hit here and then go up that little edge and then down. So I put these here so that it can come hit that and then go to the left or right and still drain out. So that goes in all across. And then we put another layer of ice and water shield across. So now, once again, we have this very nice monolithic setup. So all of that can work well. Next, we have to start understanding what our gable flashing is. And the gable flashing is the end, the part that has the slope in it. And we have a couple drawings here. This is kind of confusing, so let's start with the upper left drawing. So first of all, we have this straight line here, and it says bend panel 1 inch at 90 degrees. This is the actual roofing panel. So this is the last panel, and I'm going to come over here. It's going to come in and bend up. And we have that up bend so that water that comes here will not tend to go over the top. And if it does go over the top, you notice this support flashing has this little raised part here. So that essentially just creates a channel here. Gives us both space for the screw and gives us space for water. So if water makes it past this guy and this guy, it's going to go up and over and down. And then it will drain down just on that channel. And you can kind of see the same part here. So here's the support flashing, not drawn correctly, but you can see it has that, and then it's screwed down into the deck. So that's the first part of the flashing, that support flashing that looked like this. And then the next part, we have the gable cleat. And that is this flashing down here. It sits, so you put the support flashing, you put some butyl rubber tape, which is going to help seal things. And then the cleat flashing gets adhered to that, and then you screw through the side here into the wall. You can see that screw here. So that means you've attached now the gable cleat flashing is attached to, they would say fascia here. In our case, it's just the rafter because we don't have separate fascia. So that's the second piece. And then the neat part is we have the box gable flashing, which is the finish part. And it has this, at this end, it has this little, what's called a hem, an open hem. So there's a little space here. And it turns out that that space fits over the little end of the gable cleat that we've already attached. And that's what we're seeing here. So we see it kind of hooks around. And that means that this whole side of the gable doesn't need to have any fasteners in it, or any visible fasteners in it. Okay. That was a long explanation. So here's what the support cleat looks like. So we put it in, put in screws, 6 inches on center. And then it tells you that you're supposed to put sealant over them. I had some extra ice and water shield, so cut some little squares and use that instead of caulking or something like that. And then it was finally time to start putting down the panel. And the first panel has to kind of be trimmed. You remember we had that little up part. And essentially I just trimmed part of one of the raised ribs. So it's kind of pushed back there. And then you just start working your way along. You put down a panel and it's screwed every 6 inches. And then the next one comes along and it's attached by two things. First of all, it's attached by the screws, very obviously. And then that little cleat part that we put out, remember I said we bent the panel under, that also attaches it on. So you just put these on in 20 screws per, and here's a closer picture of what that cleat looks like. So here we have the drip edge. This little part here is that cleat that we put on, and then this is the main panel bent underneath so that it catches. And I haven't decided yet. There are two things you could do. You could crimp this all the way back, but I'm kind of thinking I'm going to leave it the way it is now, because what that means is water comes over the edge, it hits this edge, and it just drops down. where otherwise water is going to hit this edge and it's going to kind of wick back underneath this. And I don't think that would cause a problem, so maybe I'll go and fix this and crimp it, but I'm not really sure it's required. So you just keep working your way along and you eventually get to this other side. And something you might notice about these tops is the tops, we had at the bottom, we had to cut a little slit and bend down, and here we had to cut a couple slits and then bend up. And I'll talk about that a little bit more when we get to that flashing. So I've got these, and these just went on pretty quickly. And then finally we get to this end, and we need to create this flashing. And this flashing was a huge pain. This last panel was a huge pain to get correct. It took about an hour and a half to get that. And the reason was, normally, we have this little part which would hook on the last panel, and then over here on this side, we'd have the part with the flange we screw into. And I needed to cut a nice clean line to get this to bend up the way I needed it to bend up. And I couldn't do that with snips directly because of the other piece, the flange piece. So I had to cut the whole flange off, the whole length, with a angle grinder, which was a pain. Hard to get a good line, and the other problem is that it puts shredded metal particles all over, and if you leave those sitting on the panel, they can cause it to rust. So essentially you do all of this and you get it all ready, then you have to do a really good job of cleaning off all of the residue if you don't want your panels to look crappy. So cut it with the angle grinder, cut it again with shears by hand to get the line that I actually needed, and then work your way along here with the special tool that you buy from your metal roof people. The same thing I was using to do like this bend under here and the bend under and the bend up at the top. Use that same panel tool and work your way all along here, and then finally you get something like this. And just to make it a little more fun, the measurements weren't quite perfect, so this needed to be a little less than this, and that was just a lot of fun. It's especially fun because this is the last panel. You're really hoping it works well, but everything here is special order, and if you mess up, you're talking 3 or 4 or 5 days probably until you can get a new panel. I don't know, maybe you could go up and pick one up yourself, but it's going to really complicate things. Luckily, it fit really nicely. I built a little prototype to help ensure, and it fit nicely, and then we can go on to the next step of the flashing. And this is the little cleat that's attached on the outside. So you can see it come down. It kind of looks like it has a drip edge. It really just has this hook edge. And that's what it looks like. So come back, and then there's a little cut down at this end to do that. So we put that cleat on, and then you can take the big one and slide it on from the end. And this is the final fit. So I put it on once, slid it all the way over to mark for this notch, and then you just slide it all again, and it covers up all of these. And then you come back and put a little row of screws with neoprene washers. So these gable ones are because it's standing seam, you don't have any fasteners visible through any of this. You have just this little series of fasteners. And I'm pretty happy how that came out looking. And here's a view from the other side. And you can see that's a really clean look. So we've gotten this side all installed. All the flashing is done there. We have the gable ends. The only thing we have is this flashing up top. So back to our diagram again. This is called a hemmed end wall. So what we have is this panel end that we bent up, and we already did that on all those. We have what's called a foam closure, which is really just a piece of foam that is cut to fit between the panels nicely. And then we have another very simple piece of flashing. So it just has a vertical part and then a horizontal part. And the vertical part goes under your wall panel or under your siding, and then the horizontal part is going to get screwed into the top of these ribs. So here's a side view. You can see that's the top of the panel that's turned up. This black part is the foam closure, and then this is just the flashing. And you have kind of a problem. This is actually the second piece. You can see there's a piece there. But you kind of have a problem in that you can't actually bend this to go under the siding. There's not enough room, only about 2 inches here. So what you end up doing is taking a bunch of nails out next to it. So this part is free, and then we could slide it up underneath. And then finally you work your way along, nail in to make sure that the flashing is attached well, and then screws across into the ribs. And you essentially, when you nail it in, you make sure it's pulled up a little so that I have positive slip going this way. So any water here will run down. And that's a slightly farther back picture. And that's pretty much done. So we have gable flashing all nice and tight, and we have the head wall flashing, and this is going to work pretty well. And then there's another final picture from the end. Cleaned up all of the tools, except for this one ladder, which I think I'm going to need some more, and put back some of the furniture. So this is a nice little solo stove fire pit, which is really cool, on a kind of ugly movable base that I made. And then over here, this is kind of our nicer furniture, the stuff that was always getting wet. So I just kind of put it back under here to see what it would look like. So, interesting question, what tools did you use? And before I put all the tools away, I decided to do a couple pictures. 3 ladders here, so small step ladder, big step ladder in fiberglass, and then an extension ladder. It's my small extension ladder. And having 2 step ladders was really useful here when I was doing the posts and those beams, because I'd go from one end to another back and forth a few times, and not having to move the ladders was considerably easier. It's also really nice to have the height of the tall one sometimes. So in the foreground, we have the concrete tools. This is a nice mixing trough. I recommend this highly over a wheelbarrow. It just works much better. Standard shovel, and then this is a concrete hoe. It's a normal hoe, but it has two holes in it. And then some sort of plastic thing I used, and kind of messed up rusted trowel. So that's kind of the big stuff. I took all the small tools and actually laid them out on a piece of OSB. So I'm not going to talk through all of them. Well, maybe I'll talk through most of them. So compound miter saw in the back. This is a drywall square that I use to help lay things out. Hammering, clamping. Particle mast is really important. This is goggles. I always wear safety glasses, typically bifocal safety glasses. But when you are grinding and cutting cement or concrete, you really need more protection. So these go on top of that, and the protection here kind of keeps chips and dust out of my eyes. I also use the shop vac to try to pull as much in as possible. Hearing protection, little digital label, string line, tape measures, and then clamp land. I have these nice Irwin clamps that I really like, the quick grips. Nice old Craftsman C-clamps. And then over here is Harbor Freight. These small ones with the twist are actually decent quality, and they're pretty easy to use. These ones are knockoffs of the Irwins. And the problem is, because of patent reasons, the release is horrible. So Irwins have this nice, easy to pull thing that will release the clamp. The Harbor Freight ones have these tiny little tabs, and if you pull these really tight, you may actually have to hit those with something to get them to release. And in the foreground, we have my nice Craftsman level that I only use carefully. And then on the right, we have my crappy level. Okay, so what do we have here? Sledgehammer in the back. My Makita drill driver set. So this is the impact driver. This is the drill, both brushless. I've had really good luck with Makita, and these are just wonderful. This weird looking thing is a magnetic pickup. So basically this part at the bottom is black plastic, and it has a couple of magnets in it, and then there's a rod inside that you can use to lift it. So when you have lots of flashing pieces or other stuff on the ground, you just swing this around, and they all stick to the bottom, and then you put it over the trash and pull up on the rod, and they all fall off. So really useful tool. Shop vac, obviously, this is a panel carry. If you're moving plywood or drywall or anything like that, this is wonderful. It hooks underneath, and then you can easily put a hand on the handle and the other hand at the top of the panel. Far easier than carrying it otherwise. This is the tool from the metal roof company that you use to bend over or under the roofing. That's pretty nice. What else do we have? The other thing, this is actually a welding tool. Using for holding panels together, and that was really useful when this other tool wouldn't work. A good set of shears. I did a lot of flashing and other cutting, and these were very, very useful. What else? Putty knives. This is a 12-inch socket extension, and the reason I have it here is that it happens to be a 1/2-inch shaft. So when I was drilling those holes to hold the cross beams on, you could just take this and jam it in, and it would hold the thing so it wouldn't fall. This is a really important tool. It's a little awl, so it's hardened and sharpened at that end. And the screws that I use to attach everything are what are called self-drilling. And if you hold them against something on the sheet metal long enough, they will drill through, but they don't really work that well. So I found it was much easier to just take this awl and hit it with a hammer a couple times, and that would make a hole, and that just made everything go much better. And rest of this, adjustable wrench socket to attach the hardware, vice grips, a couple squares, and then some caulk gun for the caulking. This is Silkaflex. I think it's polyurethane, and that's what I used. And then this nice little magnetic holder for nails that I use for siding nails. So after I packed all that up, that went back into the garage. I thought you'd appreciate the garage mess photo. That photo plus this photo, and you can see I have quite a bit of stuff to put away. But that will happen another day. So time. I went back and looked. The materials showed up in my driveway on September 16th, and I spent about 10 days getting all the wood prepared. And that's sanding all the faces and then finishing them and waiting for the finish to dry. And on some of them, like the 6x6s, you can only finish 2 faces because they're all going to show, and then you need to flip it over. You need to wait for it to dry and then flip it over. So that took about 10 days. And then I started cutting the concrete on September 27th, and then I finished the flashing on Friday, October 9th. Generally, this was working anywhere from half to full days, somewhere 3 hours, anywhere from 3 hours to 7 hours. I took 1 day off during that time, or I didn't do any work. So rough guesstimate, 22 days, probably about 120 hours total. That doesn't count any of the Fusion 360 design work or any of the other research that I did to figure out what I was going to do. And cost, this time I actually kept receipts, so I have pretty good cost. And the roofing was a little less than $950. That included, I think, a $70 charge for just an order crate charge. Which is quite a bit less than the polycarbonate would have cost. The lumber, wow, lumber prices have gone up just ridiculously this summer, and that was $1,078. And I think if I'd done it like last year, it probably wouldn't have been more than $750. The ice and water shield was $240. The finish, I only needed 1.25 gallons, but that meant 2 gallons. It was about a little over $50 a gallon. All of the connectors, so joist connectors, those angled connectors, the post bases, and then the little other connectors plus those cost $200. All the hardware, it's all the screws, all the threaded rod, the nuts, the plates, everything there. $283, as close as I can tell, and that puts a total just under $2,900, which is pretty good. My goal was about $2,000 for the big stuff, and then I figured the other stuff would push us close to $3,000. And because my state has sales tax, our out of pocket was $31.44. So that was the project, and I hope you enjoyed the slideshow. Thanks.